NENOMATICA, where mathematics meets YouTube excellence. Exponential equations. Welcome to our math tutorial. Today we'll learn how to solve exponential equations. We'll work through two different examples to help you understand the key concepts and techniques. Let's start with our first example. We need to solve the equation where 1/2 raised to the power of 5 minus x equals 2 to the power of 95. To solve this, we'll start by noting that 1/2 can be rewritten as 2 to the negative 1 power. So we have 2 to the negative 1 power raised to 5 minus x. Next, using the power rule for exponents, when we have a power raised to another power, we multiply the exponents. So 2 to the negative 1 raised to the power of 5 minus x becomes 2 to the power of negative 1 times 5 minus x, which simplifies to 2 to the power of x minus 5. Now we have 2 to the power of x minus 5 equals 2 to the power of 95. When the bases are the same, we can equate the exponents. So x minus 5 equals 95. To solve for x, we add 5 to both sides. So x equals 95 plus 5. And our final answer is x equals 100. Here's an important rule to remember when solving exponential equations. When we have expressions with the same base, we can equate the exponents. This is a key property that makes solving exponential equations possible. Now, let's move on to our second example, which is more complex. We need to solve the equation 3 to the power of 10 multiplied by 3 to the power of 20 multiplied by 3 to the power of 30 multiplied by 3 to the power of 40 multiplied by 3 to the power of x minus 3 to the power of x plus 99 equals 2 multiplied by 3 to the power of 9. Let's start by simplifying the left side of the equation. Using the product rule of exponents, when we multiply powers with the same base, we add the exponents. So 3 to the power of 10 plus 20 plus 30 plus 40 plus x minus 3 to the power of x plus 99 equals 2 times 3 to the power of 9. Next, let's add up the exponents in the first term. 10 plus 20 plus 30 plus 40 equals 100. So we have 3 to the power of 100 plus x minus 3 to the power of x plus 99 equals 2 times 3 to the power of 9. We can factor out common terms on the left side. 3 to the power of x times 3 to the power of 99 minus 3 to the power of x plus 99 equals 2 times 3 to the power of 9. Simplifying further, we get 3 minus 1 multiplied by 3 to the power of 99 plus x equals 2 times 3 to the power of 9. 3 minus 1 equals 2. So we have 2 times 3 to the power of 99 plus x equals 2 times 3 to the power of 9. Dividing both sides by 2, we get 3 to the power of 99 plus x equals 3 to the power of 9. Again, when the bases are the same, we can equate the exponents. So 99 plus x equals 9. Subtracting 99 from both sides, we get x equals 9 minus 99. And our final answer is x equals negative 90. To summarize what we've learned, first, remember that when solving exponential equations with the same base, we can equate the exponents. Second, use the properties of exponents to simplify complex expressions. When multiplying powers with the same base, add the exponents. And when raising a power to another power, multiply the exponents. Finally, basic algebraic operations like factoring can help simplify complex exponential expressions. With these techniques, you can solve many types of exponential equations. Thanks for watching. Practice these techniques with different examples to build your confidence in solving exponential equations. Let's solve this step by step. First, we'll use the properties of exponents to rewrite our equation. Notice that all terms contain 2 to the power of something. We can factor out 2 to the x from each term by rewriting each term using the exponent property that says a to the power of m times a to the power of n equals a to the power of m plus n. So we get 2 to the x times 2 to the power of negative 1, plus 2 to the x, plus 2 to the x times 2 to the power of 1, plus 2 to the x times 2 to the power of 2 equals 15. Next, we'll evaluate the powers of 2. 2 to the power of negative 1 equals 1/2. 2 to the power of 1 equals 2. And 2 to the power of 2 equals 4. So our equation becomes 2 to the x times the quantity 1/2 plus 1 plus 2 plus 4 equals 15. Let's add up the terms inside the parentheses. 1/2 plus 1 plus 2 plus 4 equals 7.5. So our equation simplifies to 2 to the x times 7.5 equals 15. Now, we can solve for 2 to the x by dividing both sides by 7.5 or 15 over 2. 2 to the x equals 15 divided by 15 over 2. This simplifies to 2 to the x equals 15 times 2 over 15, which is just 2. Finally, to solve for x, we need to take the logarithm of both sides. Since 2 to the x equals 2 and 2 to the first power equals 2, we can conclude that x equals 1. Let's verify our answer by substituting x equals 1 back into the original equation. 2 to the power of 1 minus 1 is 2 to the 0, which is 1. 2 to the power of 1 is 2. 2 to the power of 1 plus 1 is 2 to the power of 2, which is 4. And 2 to the power of 1 plus 2 is 2 to the power of 3, which is 8. Adding these up, we get 1 plus 2 plus 4 plus 8, which equals 15. So our answer of x equals 1 is correct. Now, let's look at a more complex example. For this example, we'll use exponent properties to simplify both the numerator and denominator. Let's start with the numerator. We have 3 to the power of 2x plus 1 plus 3 to the power of 2x. Using exponent properties, we can rewrite 3 to the power of 2x plus 1 as 3 to the power of 2x times 3 to the power of 1, which is simply 3 to the power of 2x times 3. Next, let's work on the denominator. First, notice that 8 to the power of x is equal to 2 to the power of 3x, since 8 equals 2 cubed. So 4 times 8 to the power of x becomes 4 times 2 to the power of 3x. Also, 16 equals 2 to the fourth power. So 2 to the power of 3x times 16 becomes 2 to the power of 3x times 2 to the power of 4, which equals 2 to the power of 3x plus 4. Now, let's simplify both the numerator and denominator further. In the numerator, we factor out 3 to the power of 2x to get 3 to the power of 2x times the quantity 3 plus 1, which equals 3 to the power of 2x times 4. In the denominator, we factor out 2 to the power of 3x to get 2 to the power of 3x times the quantity 4 plus 16, which equals 2 to the power of 3x times 20. Simplifying further, in the numerator, we get 3 to the power of 2x times 4. In the denominator, we get 2 to the power of 3x times 20. So our equation becomes 3 to the power of 2x times 4 divided by 2 to the power of 3x times 20 equals 9 over 40. Simplifying the fractions, we can divide the numerator and denominator by 4 to get 3 to the power of 2x divided by 5 times 2 to the power of 3x equals 9 over 40. Multiplying both sides by 5 times 2 to the power of 3x, we get 3 to the power of 2x equals 9 times 5 times 2 to the power of 3x divided by 40. Simplifying the right side, we get 3 to the power of 2x equals 9 times 2 to the power of 3x divided by 8. Now, we need to create a ratio of similar bases. Notice that we have 3 to the power of 2x on one side and 2 to the power of 3x on the other. To make progress, we'll convert this to a form of the same base raised to the power of x. We can rewrite this as the fraction 3 to the power of 2x divided by 2 to the power of 3x equals 9 divided by 8. This can be rewritten as the quantity 3 squared over 2 cubed raised to the power of x equals 9 over 8. Now, note that 3 squared equals 9 and 2 cubed equals 8. So this becomes the fraction 9 over 8 raised to the power of x equals 9 over 8. Simplifying, we have the quantity 9 over 8 raised to the power of x equals 9 over 8, or the fraction 9 over 8 raised to the power of x equals the fraction 9 over 8 raised to the power of 1. Finally, since the bases are the same on both sides, the exponents must be equal, so x equals 1. Let's verify this answer by substituting x equals 1 back into the original equation. When x equals 1, the numerator becomes 3 to the power of 3 plus 3 to the power of 2, which is 27 plus 9, or 36. The denominator becomes 4 times 8 plus 8 times 16, which is 32 plus 128, or 160. And 36 divided by 160 equals 9 divided by 40. So our answer of x equals 1 is correct. To summarize, when solving exponential equations, Step 1. Use properties of exponents to simplify the equation and factor out common bases when possible. Step 2. Try to get the equation in the form where one side has a single exponential term. Step 3. If both sides have the same base raised to different powers, equate the exponents to solve. And step 4. If different bases are involved, try to rewrite the equation in terms of the same base or use logarithms. Always verify your answer by substituting back into the original equation. Thanks for watching. Let's look at this example. We need to solve for x in the equation. 3 to the power of x minus 2 times 2 cubed times 8/3 to the power of x times 9 over 64 to the power of 2x equals 9 over 64. Let's begin solving this step by step. First, we'll use the property that says a to the power of m times a to the power of n equals a to the power of m plus n. So we can rewrite 3 to the power of x minus 2 as 3 to the power of x times 3 to the power of negative 2. We also rewrite 9 over 64 to the power of 2x as 9 squared over 64 squared to the power of x. Now, we group together the terms with x as the exponent. We see that 3 to the power of x times 8/3 to the power of x can be rewritten as 3 times 8/3 to the power of x. This simplifies to 8 to the power of x. Let's simplify further. 3 times 8/3 equals 8, so we have 8 to the power of x. Also, 3 to the power of negative 2 equals 1 over 9, and 2 cubed equals 8. Now, we need to move all terms with x to the left side of the equation, and all terms without x to the right side. We divide both sides by 1 over 9 times 8, which gives us 9 times 9 divided by 8 times 64 on the right side. Next, we can combine the terms with x as the exponent on the left side of the equation. This gives us the expression 8 times 81 over 64 squared to the power of x. On the right side, we have 9 squared over 8 times 64 to the power of 1. Since both sides of the equation have the same base, the exponents must be equal. Therefore, x equals 1. Let's solve this example. We have the equation 1 over 49 raised to the power of x minus 3 over 2 equals 7 raised to the power of 4 minus x. Our first step is to rewrite the fraction 1 over 49 as 49 to the power of negative 1. This is because any number to the negative power equals 1 over that number. Next, we'll express 49 as 7 squared. Since 49 equals 7 squared, we can rewrite 49 to the negative 1 as 7 to the power of negative 2. Now, we'll use the exponent property that states when we have a power raised to another power, we multiply the exponents. So 7 to the negative 2 raised to the power of x minus 3 over 2 equals 7 to the power of negative 2 times x minus 3 over 2. Let's rewrite negative 2x plus 3 as 3 minus 2x to match the format shown in our example. When we have the same base raised to different exponents and the expressions are equal, the exponents must also be equal. So we can set 3 minus 2x equal to 4 minus x. Now we've converted our exponential equation to a linear equation. Let's solve for x by first subtracting 4 from both sides. Simplifying the left side, we get negative 1 equals x. Therefore, x equals negative 1 is our final answer. We need to solve the equation 5 raised to the power of x plus 3 equals 25 times 2 raised to the power of 5x plus 5. To solve this equation, we'll work on getting similar bases on both sides. First, let's move the 25 to the left side by dividing both sides of the equation by 25. Now, we can rewrite 1 over 25 as 5 raised to the power of negative 2, since 25 is equal to 5 squared, and dividing by 25 is the same as multiplying by 5 to the negative 2. Next, we can combine the exponents on the left side, using the property that when we multiply powers with the same base, we add the exponents. So 5 to the negative 2 times 5 to the x plus 3 becomes 5 to the power of negative 2 plus x plus 3, which simplifies to 5 to the power of x plus 1. Now, we need to find a way to compare these expressions with different bases. Looking at the right side, we can factor out the common factor from the exponent. 2 to the power of 5x plus 5 can be rewritten as 2 to the power of 5 times quantity x plus 1. Now, we can use the power of a power property to simplify the right side further. 2 to the power of 5 is 32, so we have 5 to the power of x plus 1 equals 32 to the power of x plus 1. Since the bases are different, but the exponents are the same, we can conclude that the only way this equation is true is if the exponent x plus 1 equals 0. Finally, solving for x, we get x equals -1. Let's move on to our second example. The equation is 7 raised to the power of 2x squared plus 1 minus 49 raised to the power of x squared equals 6 times 7 to the power of 4 times 49 squared. This equation looks more complex, but we'll solve it step by step. First, let's rewrite the left side of the equation. We can split 7 to the power of 2x squared plus 1 as 7 to the power of 2x squared times 7 to the power of 1. And we can also rewrite 49 to the power of x squared as 7 squared to the power of x squared. Now, let's continue simplifying. 7 squared to the power of x squared is equivalent to 7 to the power of 2x squared. So we have 7 to the power of 2x squared times 7 minus 7 to the power of 2x squared. Now we can factor out the common term 7 to the power of 2x squared from the left side. We get 7 to the power of 2x squared times the quantity 7 minus 1 equals 6 times 7 to the power of 4 times 7 to the power of 4, since 49 squared is equivalent to 7 to the power of 4. Simplifying further, we get 7 to the power of 2x squared times 6 equals 6 times 7 to the power of 8, since 7 to the power of 4 times 7 to the power of 4 is 7 to the power of 8. Now we can divide both sides by 6 to get 7 to the power of 2x squared equals 7 to the power of 8. Since the bases are the same, the exponents must be equal. So 2x squared equals 8. Dividing both sides by 2, we get x squared equals 4. Finally, taking the square root of both sides, we get x equals plus or minus 2. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.